So another problem from the gravitation. The value of acceleration of due to gravity is given at a height h is equal to r by 2. R is the radius of the earth. It is again equal to g1 at a depth d below the surface of the earth. Then the ratio of d by r is equal to. So this is earth and this is radius of the earth. So now at a height h, that h is equal to r by 2, the value of g is g1. The value of g is g1. At a depth d, its value again g1. G1. Then the ratio of d by r is equal to. Right. We know that formula. What is that formula here? GH is equal to, we know that G by 1 plus H by R whole square. GH is equal to G by 1 plus H by R whole square. GH means G1 is equal to G by 1 plus H is equal to R by 2 by R whole square. So now G1 is equal to G by 1 plus 1 by 2 whole square. 1 plus 1 by 2 whole square. Here R cancel. 1 plus 1 by 2 whole square. G1 is equal to G by 1 plus 1 by 2. 3 by 2. 3 by 2 means here 3 by 2 whole square means 9 by 4. That is equal to 4G by 9. 4G by 9. 4G by 9. 4G by 9. But at the depth d, again its value is g1. So we know that gd is equal to g into 1 minus d by r. Gd at depth d, the value is g1 is equal to g into 1 minus d by r. Again its value g. So g1 is equal to how much we write here? 4g by 9. This is equation 1. This is equation 2. From 1 we write that g1 is equal to 4g by 9. 4g by 9. So 4g by 9 is equal to g into 1 minus d by r. Gg cancel. Gg cancel. Now we write here d by r is equal to 1 minus 4 by 9. That is equal to what we write here? 5 by 9. So our option is option 3. Option 3 is our correct option. So let us discuss another problem here. A hollow spherical shell at outer radius R floats just submerged under the water surface. Just submerged. So just submerged means this is the figure. The inner radius of the shell is R, outer radius of the shell is capital R. The specific gravity of shell material is 27 by 2 with respect to water at a relative density. Specific gravity is equal to 27 by 8. Specific gravity means what? Density of the object by density of the water. That is equal to here density of the body by density of the water. They given. So whenever this spherical ball is just submerged, then what happens? There is a buoyancy force is acting upward direction and downward direction. This buoyancy force is equal to weight of the body. Weight of the body. So whenever a body is displaced, whenever a body is placed in a water, it displaces some amount of water. Here just submerged means what? Total volume of the body is displaced by the water. Okay, so it displaces some amount of some volume of water. So that means here FB is equal to mg. It displaces some amount of water whose volume is equal to volume of the complete body. So buoyancy force is acting upward direction. So buoyancy force is equal to volume of the body displaced into density of the water into G is equal to, here M means volume of the body, volume of a body into density of the body into G. Here complete volume of the body is displaced by the water. Okay, volume of the body is displaced. This okay, now volume of the body displaced here. So volume of the body is 4 by 3. Complete volume of the body is 4 by 3 pi r cube. 4 by 3 pi r cube into rho w into G is equal to volume of the body is equal to 4 by 3 pi. Here volume of the body means this volume of the body. 4 by 3 pi into r cube minus r cube into density of the body into G. Density of the body into G. Here this is volume of the body displaced. Volume of the body displaced. Now we write here 4 by 3 pi cancel and G cancel. Now we write here rho w by rho b. Rho w by rho b is equal to what we write here, r cube minus r cube divided by r cube. So rho w by rho b is equal to 1 minus small r cube by capital R cube. Rho w by rho b, that means here rho b by rho w is equal to 27 by 8. 27 by 8. Now here what we get, 8 by 27. 8 by 27 is equal to 1 minus r by capital R cube. So small r cube by capital R cube is equal to 1 minus 8 by 27. 1 minus 8 by 27. Now here small r cube is equal to capital R cube into 1 minus 8 by 27 whole power 1 by 3. This is also whole power 1 by 3. Small r is equal to. So small r is equal to r into 1 minus x whole to the power of n, binomial theorem. 1 minus nx. 1 minus nx, that means 8 by 27. So r is equal to here r into 1 minus 8 by 81. So we write here r is equal to r into 72 by 81. Small r is equal to, so here 9 9s are 9 8s are. 81 minus 8. 81 minus 8 is equal to how much? 73. Nearly this is cancelled. 9 9s are 9 8s. That is equal to 8 by 9 capital R. So our option is here, option 2. Option 2 is correct option. So whenever the complete volume of the spherical body is displaced, we write volume of the body displaces 4 by 3 pi r cube. Okay. Now how can you find out the volume of the spherical body? That is the formula, 4 by 3 pi into r cube minus small r cube. Outer volume minus inner volume into density of the body into g. Density of the body into g. Okay. So this is the 13th problem. So let us discuss another question. In a resonance tube experiment, when the tube is filled with water up to a height 17 centimeters from the bottom, it resonates with a given tuning fork. Okay, that means here L1 they given 17 centimeters. 17 centimeters. So this is a resonance tube. When the water is filled with 17 centimeters from the bottom, it resonates with a tuning fork. This is a tuning fork. Now, it resonates with the same tuning fork when the water level occurs at a height 24.5 centimeters. 24.5 centimeters from the bottom. So 24.5 centimeters. 24.5 centimeters, that is second resonance is formed at a height L2 is equal to 24.5 centimeters. What is the frequency of tuning fork? We know that V is equal to 2n into L2 minus L1. V means what? 330 is equal to 2 into n into L2 means 24.5 minus L1 17. This is centimeter. You should convert it into meters, 10 to the power of minus 2. So 330 is equal to 2 into 7.5 into 10 to the power of minus 2 into n. So n is equal what we write here, 330 by 15 10 to the power of minus 2. So n is equal to 330 by 15 into 10 square. That is equal to what we get here, 15 2s are 22 into 10 square. So that is equal to 2200 Hz. 2200 Hz. So our option is option 1. So a solid sphere of radius capital R carries a charge Q plus Q distributed uniformly over its volume. A very small point like piece of its mass m gets detached from the bottom of the sphere and falls down vertically under gravity. This piece carries a charge Q. If it acquires speed v when it has fallen through vertical height y, then v square is equal to how much? So this is a solid sphere. So total charge on this solid sphere is q plus small q, which is uniformly distributed. A small mass of charge plus q is gets detached from the bottom of the sphere, and reaches to the ground. This is ground. Now this point treated as B and this point treated as A. Now with what velocity it reaches to the ground, that is we are going to find out. From the energy conservation we solve this problem. So this is a small charged particle q. This gets detached from the solid sphere and falls down. So total energy at A is equal to total energy at B. Total energy at A, potential energy plus kinetic energy. It has no kinetic energy. Okay, initial kinetic energy is 0, falls down vertically 0 plus, and it has a gravitational potential energy, that is mgy plus, and it has a electrostatic potential energy. Here this is a charge small q detached from this sphere, and gravitational potential energy is equal to what we write here, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught q into small q divided by r is equal to, when it reaches to the ground, its potential energy is 0, but kinetic energy is not 0, of mv square plus, and gravitational potential energy is 0. Potential energy and electrostatic potential energy is, this is when it reaches to the ground, the electrostatic potential energy is 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, what we write here, q into q divided by, here the distance is y plus r, y plus r, y plus r. Now we want to find out what v square. So here we write of mv square is equal to, we write of mv square is equal to mgy plus 1 by 4 pi epsilon naught capital Q small q by r minus 1 by 4 pi epsilon naught capital Q small q by y plus r. So of mv square is equal to mgy plus here 1 by 4 pi epsilon naught into capital Q small q taken as common, 1 by r minus 1 by y plus r. Now of mv square is equal to mgy plus 1 by 4 pi epsilon naught capital Q small q, here take r into y plus r, so that is equal to y plus r minus r. Okay, r into y plus r taken as LCM, r gets cancelled. Now of mv square is equal to, we write here mgy plus 1 by 4 pi epsilon naught capital Q small q into y by r into y plus r, r into y plus r. So we write here v square is equal to 2mgy divided by m plus what we write here, 2q small q y divided by 4 pi epsilon naught m into y plus r into r. So we will get v square is equal to, gets cancelled, 2zy plus here 2zy plus 2q small q y divided by 4 pi epsilon naught m into y plus r into r. V square is equal to, take 2y common, g plus what we write here, q into small q divided by 4 pi epsilon naught m into y plus r into r. This is our answer, v square. So our correct option is here g plus 2y into, that means here our correct option is so next problem. A galvanometer of resistance G, capital G, is converted into voltmeter of range 0 to 1 volt by connecting a resistance R in series with it. The additional resistance that should be connected in series with R1 to increase the range of voltmeter 0 to 2 volts will be. So here this is galvanometer. When the resistance R1 is connected series to the galvanometer, it becomes a voltmeter. We know that it measures voltage range 0 to 1 volt. So here we know that V is equal to Ig into Ig means the current passing through the galvanometer, Ig into G plus R1. So equation 1. But to increase the range of voltmeter, another additional resistance also connected series to the R1 resistance. Series to the R1 resistance, so that it measures voltage range 0 to 2 volts. 0 to 2 volts. So here 1 is equal to Ig into G plus R1, equation 1. Now, whenever another additional resistance R2 is connected, the voltage is measured up to 2 volts. Ig into G plus R1 plus R2. This is equation 2. Now, divided equation 2 with 1. 2 by 1 is equal to G plus R1 plus R2 divided by G plus R1. So, G plus R1 plus R2 is equal to 2G plus 2R1. Now, we want to find out what R2 is equal to 2G plus 2R1 minus G minus R1. So, R2 is equal to what we get here, G plus R1. So, R2 is equal to G plus R1. So, our option is option 4. Option 4. This is our answer. So, let us discuss another question. Number of molecules in a volume of 4 centimeter cube of a perfect monoatomic gas at some temperature T and a pressure of 2 centimeters mercury is close to how much? We get an approximate value. We know that here PV is equal to NKT. Here P is equal to, we write rho GH. So, in this question, density of mercury, rho is equal to 13.6 into 10 to the power of minus 3 into 10 to the power of 6 kg per meter cube. So, rho is equal to, we write here 13.6 into 10 cube kg per meter cube. The given gram per centimeter cube, that should be converted into kilogram per meter cube, G. So, G value is nothing but how much? 9.8. 9.8. H, that is equal to here, H is equal to the given 2 centimeters. H is equal to the given 2 centimeters. So, 2 centimeters of Hg, 2 into 10 to the power of minus 2 meters. Right. So, V volume 4 centimeter cube, that is equal to 4 into 10 power minus 6 meter cube. So, T temperature, what they given temperature? Here the given temperature as we are finding out the temperature. So, here total energy in monoatomic gas E is equal, we know that 3 by 2 kT. So, T is equal to, we write here T is equal to 2E by 3K. 2E by 3K. substitute these values in above equation. So P is nothing but 13.6 into 10 cube, G is nothing but 9.8, 2 into 10 to the power of minus 2, P is nothing but 4 into 10 to the power of minus 6 is equal to, here N, K, T value is nothing but 2E by 3K, K cancel. So 13.6 into 10 cube, 9.8 into, right here, 2 into 10 power minus 2, 4 into 10 to the power of minus 6 is equal to, K cancel, N into 2 into E, energy, 4 into 10 to the power of minus 14 ergs, that should be converted into joules. That is equal to 4 into 10 power minus 14, 1 erg is equal to 10 to the power of minus 7 joules. So N is equal to, we write here, 13.6 into 10 cube into 9.8 into 2 into 10 to the power of minus 2 into 4 into 10 to the power of minus 6 divided by 2 into 4 into 10 to the power of minus 21. 4 into 10 to the power of minus 21. So I solved it on my rough book. We get here 399.8 into 10 to the power of 16. That is equal to, here number of molecules is equal to 3.99 into 10 to the power of 18. So N is equal to 4 into 10 to the power of 18. Okay, this is our answer. So next question, an electron is constrained to move along the y-axis with a speed 0.1 c. C is the speed of light. In the presence of electromagnetic wave whose electric field E is equal to 30J sin 1.5 in 10 square t minus 5 in 10 to the power of minus 2 x volt per meter. The maximum magnetic force experienced by the electron will be. So here they given E is equal to 30J sin 1.5 into 10 to the power of 70 minus 5 into 10 to the power of minus 2x volt per meter. We know that here wave is propagating along positive x direction. Wave is propagating along positive x direction. Electron is moving along y direction. So we want to find out what is the direction of magnetic field. We know that here E bar cross B bar equal to C bar. So here E bar, that is equal, here the direction of electric field is J cross, we don't know direction of magnetic field, is equal to C bar. C bar, wave is propagating along positive x direction. Here they given omega t minus, wave is propagating along positive x direction, that is I cap. So B is nothing but K cap. B is the direction of magnetic field is along Z direction. Here they asks maximum magnetic force, F maximum is equal to QVB sin 90, theta is equal to 90, maximum magnetic force. F maximum is equal to EVB sin 90 is 1. Okay. Here velocity, the angle between velocity of the electron and magnetic field is 90 degrees. Electron is moving along the upward direction, magnetic field is along the z direction. So that angle is 90 degrees. So we want to find out here the maximum magnetic field. We know that E naught is equal to C into B naught. So B naught is equal to here E naught by C. Maximum electric field, that is equal 30 divided by 3 10 to the power of 8, that is equal to, here what we get, 10 to the power of minus 7, 10 to the power of here minus, okay. Now F maximum is equal to, E means how much, E means 0.1 into C, 3 10 to the power of 8 into 30 divided by 3 10 to the power of 8. So here 3 10 to the power of 8, 3 10 to the power of 8 cancel, 30 into 0.13. E, charge of the electron, that is 1.6 10 to the power of minus 19. So F maximum is equal to, we get 4.8 into 10 to the power of minus 9 newtons. So our option is option 2, 4.8 into the power of minus 9. So here maximum magnetic force is equal to 0. E means here this is E, V 0.1 C, 0.1 into C means 3 10 to the power of 8 into 30 by 3 10 to the power of 8. This is cancelled. So we get here 4.8 to the power of minus 19 newtons. Okay, let us see next problem. A physical quantity Z depends upon 4 observations A, B, C, D, as Z is equal to A square B to the power of 2 by 3 divided by root C dq. The percentage error in the measurement of A, B, C are 2%, 1.5%, 4% and 2.5% respectively. The percentage error in the Z is. So here what they given, Z is equal to A square B to the power of 2 by 3 divided by root C dq. They ask the percentage error in Z is. So here delta Z by Z is equal to 2 into delta A by A plus 2 by 3 into delta B by B plus 1 by 2 into delta C by C plus 3 into delta D by D. So here delta Z by Z into 100 is equal to 2 into delta A by A into 100 plus 2 by 3 into delta B by B into 100 plus 1 by 2 into delta C by C into 100 plus 3 into delta D by D into 100. That is equal to 2 into delta A by A into 100. 2 plus here 2 by 3 into this is 1.5 plus 1 by 2 into 4 plus 3 into 2.5. So what we write here, 2 into 2, 4 plus 1 plus 2 plus 7.5. So what we get here answer, finally 14.5%. This is our answer, 14.5%. So now let us discuss another question here. What is that question here? A particle of mass 200 MeV per c square collides with the hydrogen atom at rest. Soon after the collision, the particle comes to rest, okay, and the atom recoils and gets to its first excited state. The initial kinetic energy of the particle is n by 4, then find the value of n. Here given that the mass of the hydrogen atom is 1 giga electron volt per c square. So, after collision, what is the velocity of the hydrogen atom? What is the velocity of the hydrogen atom? The initial kinetic energy of the particle is, the initial kinetic energy of the particle is, here he asks, here m2 is mass of hydrogen atom, mass of hydrogen atom, that is equal to how much? 1 giga electron volt per c square. Here m1 is mass of particle, that is equal to how much here? 100 million electron volt per c square. So, here 1 giga electron volt is equal to 1 into 10 to the power of 9 electron volts. So, this can be written as 1000 into 10 to the power of 6 electron volts, that is equal to 1000 10 to the power of 6 electron volts, that we can written as, here 1000 means how much? 10 cube into 10 to the power of 6. 1000 million electron volt, 1000 million electron volt per c square. So, this is giga electron volt per c square. Here m1 they given how much? 200 million electron volt per c square. So, here if m1 is equal to, we assume as m, then m2 is equal to what is m2 value here? 1000 million electron volt per c square, that is equal, this becomes 5m, this becomes 5m. So, apply law of conservation of linear momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1, that is m, which is coming with the velocity how much? U, before collision, before collision, before collision, before collision, plus 0, initially second particle is 0, that is equal to m1 comes to rest after collision, but m2 is nothing but 5m. What is the velocity of m2? We are going to decide. v2 is equal to mu by 5m, that is equal to u by 5, u by 5. So, during this collision, loss in kinetic energy, initial kinetic energy is equal to, initially only the particle is moving with velocity u. So, initial kinetic energy is equal to how much here? Of mu square. Initial kinetic energy is equal to, initial kinetic energy is equal to final kinetic energy, Ke final is equal to of 5m into u square of 5m into v2 square, and that means u by 5 whole square, u by 5 whole square, that is equal to what we write here? Of 5m into u square by 25, u square by 25, that is equal to, for example, initial kinetic energy we assumed as E, the final kinetic energy, what we write here, E by 5. E by 5. Loss in kinetic energy. Loss in kinetic energy is equal to initial kinetic energy E minus final kinetic energy E by 5 is equal to 4 by 5 E. 4 by 5 E. Only we find out only loss in kinetic energy. This kinetic energy is used for hydrogen atom to jump into excited state, first excited state. So, that is 10.2 electron volt. 10.2 electron volt. Energy, loss in energy required to jump excited state. This energy is utilized for hydrogen atom to jump into the excited state. Now, we find out kinetic energy E is equal to 5 into 10.2 divided by 4. That is equal to how much here? 5 into 10.5. That is equal to here 51 by 4. According to problem, the initial kinetic energy what they given, n by 4. N by 4. According to problem, the given initial kinetic energy is n by 4. So, now by comparing these two, what is the value of n here? N is equal to 51. So, n is equal to how much? 51. So, n is equal to, we get here 51. This is, now let us discuss another problem. So, here what is that problem? Let us see. Two concentric circles, circular coils C1 and C2 are placed in the xy plane. C1 has 500 tons and radius 1 centimeter. C2 has 200 tons and radius 20 centimeters. Carries time dependent current IT is equal to 5t square minus 2t plus 3 amperes, where t is in seconds. The EMF induced in C1, the EMF induced in C1 at the instant t is equal to 1 second is 4 by x. The value of x is. So, here what is the concept is, this is these are the two concentric coils. Whenever the current is passing through outer coil, due to change in magnetic flux in the inner coil, induced EMF is developed. That is, we are going to find out. So, here the angle between E is equal to, we know that d phi by dt. The angle between B and A is 0. These are in same direction. By using right hand thumb rule, these are in same direction. So, now E is equal to, we write d of dt, B magnetic field produced by outer coil, mu naught N2 I2, A. So, the flux passing through area of inner coil, pi R1 square, which has N1 tons, which has N1 tons. So, E is equal to here mu naught N2, here di2 by dt. Okay. Why? Because the current in the outer coil changes, it is variable current with respect to time, pi into R1 square into N1, pi into R1 square into N1. Right. Now, here we want to find out di2 by dt is equal to d of dt. What they given I? They given I 5t square minus 2t plus 3. So that is equal to how much we write? 10t minus 2. Okay. So here di2 by dt at t is equal to t1 seconds. At t is equal to t1 seconds, we get here 10 minus 2, that is equal to 8. That is equal to what we write here? 8 volts. Now here E is equal to mu naught, that is equal to how much here? Mu naught is equal to 4 pi into 10 power minus 7 N2, number of turns in the secondary coil 200. So di2 by dt 8 into pi into R1 square. R1 is equal to how much? Here R1 is equal to 1 centimeter. So that is equal, that convert into meters, 10 to the power of minus 2 whole square into N1. So N1 is equal to how many turns? N1 has 500 turns. So here divided by 2R. What is the radius of the outer coil? 20 into 10 to the power of minus 2. Here the magnetic field produced by the outer coil is mu naught Ni by 2R. We know that. Mu naught Ni by 2R. So here we write 2R2. So what is R2 here? R2 is nothing but 20 centimeters. 20 centimeters. So by calculating this value, we get here 32 by 4 into 10 to the power of minus 4. So that is equal to, according to given problem, 4 by x. 4 by x. So this is equal to here, what we write here? 4 8s. So here 8 E is equal to 8 into, so 10 to the power of minus 4. This can be written as 0.8 into 10 to the power of minus 3 volts, that is equal to 4 by x. 4 by x. So here 4 by x is equal to, what we write here? 0.8 into 10 to the power of minus 3 is equal to 8 millivolts. 8 that is equal to 0.8 millivolts. So 4 by x is equal to 8 by 10. 4 by x is equal to 8 by 10. So here 2 4s are 2 5s are. X is equal to what we get here? 5. X is equal to 5. So here 0.8 into 10 to the power of minus 3, 0.8 into the power of minus 3 written as 0.8 millivolts. So 4 by x is equal to 0.8 is written as 8 by 10. 8 by 10, 2 4s are 2 5s are. 4 4 cancel, x is equal to 5. So our option, that is, this is a numerical question. So what is our value here? X is equal to 5. Okay, next question we will discuss from ray optics. A compound microscope consists of an objective lens of focal length 1 centimeter and eyepiece of focal length 5 centimeters with a separation of 10 centimeters. The distance between object and objective lens at which the strain on the eye is minimum is n by 40. The value of n is. So here this is objective lens, this is eyepiece. What they given in the problem? F naught. This is objective lens, this is eyepiece. F naught is equal to 1 centimeter and eyepiece Fe is equal, focal length of eyepiece is equal to 5 centimeters. and distance between separation between them is L is equal to 10 centimeters. L is equal to how much? 10 centimeters. We know that L is equal to V naught plus UE. V naught plus UE. Right. Now, here what they given, the distance between object and objective lens. That means U naught is equal to N by 40, at which the strain on the eye is minimum. That means image is formed at infinity. So, image is formed at infinity means here image distance VE is equal to infinity. V is equal to how much? Infinity. V is the value of n is, right. So, now let us start this problem. 1 by Fe is equal to 1 by V minus 1 by U, 1 by VE minus 1 by UE, 1 by Fe 1 by 5 is equal to, we do 1 by infinity minus 1 by UE. So, here according to sign convention this becomes plus 1 by UE is equal to 1 by 5 and UE is equal to 5 centimeter. So, this is equation 1 and this is equation 2. Substitute 2 in 1. What we get here? V naught is equal to L minus UE. L is equal to how much? 10 minus UE is equal to 5, that is equal to 5 centimeters. Right. We know that 1 by F naught is equal to 1 by V minus 1 by U, 1 by V naught minus 1 by U naught. So, 1 by F naught what they given? 1 by 1 is equal to 1 by V naught 1 by 5. According to sign convention this becomes plus 1 by U naught. So, 1 by U naught is equal to 1 minus 1 by 5, that is equal to 4 by 5. So, U naught is equal to how much? 5 by 4. So, according to problem what they given? U naught is equal to what they given? N by 40. So, here 5 by 4 is equal to N by 40, 4 ones are 4 tens are. So, N is equal to what we get here? N is equal to 50. So, the value of N is equal to 50. So, this is our correct answer. A beam of electrons of energy E scatters from a target having atomic spacing 1 angstrom. The first maximum intensity occurs at theta is equal to 60 degrees. Then energy is maximum intensity, the first maximum intensity, condition for maximum intensity. Here 2d sin theta is equal to, we know that n lambda. So, for first maximum n is equal to 1, 2, d atomic spacing 1 angstrom, that is equal to 10 to the power of minus 10. T is equal to 1 angstrom atomic spacing, that is equal to 10 to the power of minus 10 meters. Sin 60 is equal to lambda. So, here 2 into 10 to the power of minus 10 into root 3 by 2 is equal to, according to lambda is nothing but we write 150 by V. 150 by V, lambda is equal to de Broglie wavelength, lambda is equal to 150 by V. Here 2 cancel, 2 cancel. So, 10 to the power of minus 10 into root 3 is equal to, here this is angstroms, root 150 by V into 10 to the power of minus 10. So, squaring on both sides, when we squaring on both sides 3 is equal to, we get 150 by V. So, V is equal to 150 by 3, that is equal to 50 volts. So what they ask, energy is equal to E into V. E into energy of electrons, that is equal V minus potential difference 50. So that is equal 50 electron volts. Okay, so this is our answer, 50 electron volts. A force F is equal to I plus 2J plus 3K newtons acts at a point 4A plus 3J minus K meters. Then the magnitude of torque about the point I plus 2J plus K meter will be root x newtons. The value of x is. So tau is equal to here R bar cross F bar. R bar is equal to, we write R2 minus R1 into F cross F bar. That is equal to here 4I plus 3J minus K minus R1 I plus 2J plus K cross F bar I plus 2J plus 3K. So here what we get here, 4I minus I, 3I, 3J minus 2J plus J minus K minus 2K cross I plus 2J plus 3K. So torque is equal to, we write here I J K. So first one 3 1 minus 2 1 2 3. So torque is equal to I into 3 plus 4 minus J into 9 plus 2 plus K into 6 minus 1. So torque is equal to what we get here, 7I minus 11J plus 5K. So magnitude of torque is equal to square root of 7 square plus 11 square plus 5 square, that is equal to 49 plus 121 plus 25 root 170 here 195, that is equal, according to problem, root x they given. So x is equal to how much value we get, 195. X is equal to 195 we get answer. So this is our answer.